Hello and welcome to another whiteboard testing video. Today we're going to talk about TRIMS. TRIMS is a mnemonic to assist you with your automation strategy, with the goal of it to encourage you to think about various things that enable you to get a good strategy and in turn create valuable automation. I've been sharing TRIMS a little bit on Twitter and LinkedIn, so if you're following me on either of those platforms, you've probably seen some of this. And I've also published a blog post just a few days ago with more in-depth explanations of TRIMS, but I thought why not complete the set and record a little video on it as well. So let's go through TRIMS. So the T stands for targeted, and the T in this instance we're trying to think about two things. We're trying to think about risk, so purposely only automating things that have a high risk. You know, there's a lot of teams that if there's a test case that exists, we automate it. Any type of edge case, let's just automate it because we can. But the more you do that, the bigger the bigger body of automated checks that you have, the longer they start to take to maintain and so forth and execute, of course. So we want to be selective, and one of the things we do that on is risk. So firstly, let's only automate things that are of real importance, that when they break, there is going to be a lot of discussions and actions that are going to need to be taken, instead of something that you might just be like, log a bug, stick it in the backlog. The second part of it is on the layer of the application. So obviously we're all accustomed to being on the user interfaces of a lot of applications when we test, but if the risk is like business, such as can we take payments, or can we process payments, can we send them to the payment provider, we want to be finding the point lower down the stack where we can implement that automated check. But then it also depends on our testability. If our testability in the team, meaning that our ability to test, if we don't have people who can do things on the API layer, then obviously we're going to have to go a layer above, but then accept the risk that really we should be doing this on the API. Let's put some plans in place to get those skills. So yeah, that's the T. T is for targeted. Think risk and think layer or seam of your application. We prefer to call them a seam within the AIT because I consider layers to be these individual things, whereas in most systems there's some sort of seam between them, so we like to say they're sewn together in some way. Could be a contract somewhere, whatever it is. I just prefer the word seam. Alright, the R. The R stands for reliable. Might be obvious, but we see so many stories about flaky automation. I've done the talk myself. I did a talk at Selenium conference on flaky automation. It happens, right? These things, there's a lot of moving parts in the automation frameworks these days. The applications, of course, continuously on the move. So we need to try and focus on reliability. So we're aiming to have checks that are reliable, that are deterministic and not flaky. We want, whenever they detect change and they go red, your build pipeline goes red, we want to have that more cases, meaning that something's really gone bad or something really significant has changed. What we don't want is to investigate it and you go, X took too long to respond again, or something slightly out of sync, or the database didn't come up in time. You know, we don't want those kind of things. We want to be alerted to things that are really important. So we want them to be reliable. Informative. So obviously if we are running all these automated checks all the time, we want them to be informative. So we want them to be well named. So it's very clear what the intent of this automated check is. So when we do see it passing, it's easy for us to digest that information, which in turn will infer further testing that takes place, or decisions to ship, or reports or evidence, whatever it may be. We get that from looking at it, so we want it to be informative. The second thing is they will fail. We want them to fail. That's the whole point, right? Or we say fail, we want them to detect change, we want them to alert us to things that are of interest. And obviously if we're targeted, then we'll be only looking at things that are important. But when they do fail, we need information. What tends to happen, or I do this a lot, is when a check fails, especially if it's something like on a user interface, I'll download the latest code and then I'll run it and I'll just stare at it. And I'm watching it and I go, yeah, failed, I know what that is, then I'll fix it. That takes time, especially if you're doing that several times a day, and that's a lot of time debugging it. Whereas what we can do now is we can take advantage of tools. We can have full logs, we can have videos, we can have screenshots, we can have application log files, we can have console log files. If you're in the API world, we can print out all the JSON, we can store the headers, we can even, we can save the whole response. My point is, we want it to tell us as much as possible. I call it giving your robot a voice. I want it to talk to me and say, Richard, I detected a change, here's some stuff. And I'll be like, yay, let's see what's interesting in that. So the I stands for informative. M stands for maintainable. Again, there's lots of information out there on this, but it is very important. We want to be writing clean code, or we want to be following good design patterns. If you're using a tool that isn't code-based, there will still be patterns that can be utilized. Perhaps there's a way of abstracting away some of your locators or some of your test data. Perhaps there's a way of using global variables or config to remove stuff away from being hard-coded. Whatever it is, there will be stuff you can do which makes it easier for your future self to maintain or other members of your team. So we want it to be maintainable. If you're writing code and you're using, frameworks that are code-based, and obviously you want it to be following good principles, good design patterns, there's lots of stuff out there, and obviously you've got programmers in your company who will be above and beyond anyone else. So ask them for advice. But whatever we can do to make it easier to maintain, because as I said, they're going to fail. And when they fail, we need to investigate, make the correct changes, get them up and running as quickly as possible, back into that pipeline, back into that CI, to get that valuable information from them. And perfectly moving into the S. The S stands for Speedy because putting an F into this didn't work, so we went with Speedy instead of fast. But basically we want them to execute fast. The quicker they execute, the quicker we get that valuable information. We want rapid feedback loops. That's one of the main goals around automation. We want to be able to push some commits and have feedback as quickly as the context and the testability allows. So we should be doing everything we can within our strategy, within our design, to try and get that feedback as quickly as possible. That could be making changes to the products, to the setup, to the environment, or it could literally be the checks themselves, writing more intelligent ways, or having quicker logic than waiting around for things to happen, or complicated setup processes that take time. So whatever it is we want to be doing, try and make them execute as quickly as possible to get that rapid feedback. But it's not a case of just running them in parallel. Obviously it takes good design and thought up front, which is why it forms part of the strategy. And in turn on that faster fix, as we said, we've mentioned on the maintainability and the informative that we want information as quickly as possible, but we also need speed in terms of getting these things back up and running. Because while the execution may be quick, if the design and the building and the maintain of them is really long, that isn't going to provide you with a rapid feedback loop. You might get quick execution, but then it takes you hours to investigate. It takes you hours then to give that information back to your team and make those important decisions. So we need every part of the process to be quick. So that's TRIMS. And then just to finish off the cheesy analogy with the mnemonic, I encourage you to look at some of your automation and see if you can trim some of it away. Can you make them smaller, faster, easier to maintain? Just trim away some of that waste that will be in your frameworks. It's been in every framework I've ever written. So yeah, bit of a play on words, but perhaps go away and trim some of your automated checks. Alright, thank you for watching. If you like these whiteboard testing videos, please subscribe to the channel. And remember, this is an open channel. If you've got a whiteboard, or you stick a piece of paper to the wall like some of them have done previously, please record your videos, send them to me, and I'm more than happy to put them on the channel. Alright, cheers for watching. Bye.